Hi and welcome back to VPN Part 2. So we left off in VPN Part 1 where we were just about to get started on step number 4, which is configure the Internet Key Exchange IKE Phase 1 ISAKMP policy and OR1 and its acronym known as HAGL. So what is all of this? Well, essentially what we're going to look to do here now, folks, is we're going to look to set up what's called a logical VPN tunnel between OR1 and OR3. So what we're going to need to do is we're going to need to agree on a set of rules or protocols that we're going to use in order to set up and to allow management traffic to go between these two VPN pairs. So again, we're going to use some well-known, if you like, protocols that are out there today to help us do this. One of them is known as Internet Key Exchange, this IKE protocol. And essentially what this is a key management protocol standard. And this is used in conjunction with IPsec standard. Okay, so what we're going to do is we're going to use this IKE framework and this standard to communicate between our OR1 and OR3. And what I'm going to do is I'm going to bring up basically some parameters, because in order to do this, guys, we have to plan out and we've got to figure out what we're going to agree to. And we'll see here that this is our phase 1 and we've got basically an IPsec phase 2. So what we'll do actually is we'll set up two tunnels. This phase 1 is our first tunnel and phase 2 is our second tunnel. What will happen in phase 1? Phase 1 will be used for management traffic between OR1 and OR2, whereas phase 2 will actually be the data traffic that we're going to be sending from PCA across to PCC. So it's really important that we get to know these terms, IKE and this ISAKMP. So what is this? So essentially IKE is a hybrid protocol that implements key exchange protocols inside the Internet Security Association Key Management Protocol. So that's what that stands for. So again, that's the Internet Security Association Key Management Protocol. Okay, it's a bit of a mouthful, but basically this is just a framework that helps us communicate between one VPN pair, in this case OR1 to OR3. So what we'll do is we're going to be using this ISAKMP to help us with our key distribution. Also, we'll see that basically what we're going to need to do is we're going to need to do what's called HAGL, this acronym here called HAGLE. You might say, what the hell is HAGL? Well, HAGL basically is this idea of how do we set up our, if you like, communication between these two pairs. So what we'll see is this H stands for hashing, A stands for Authentication Method, G stands for Diffie Hellman group, and basically L stands for lifetime, and basically E stands for our encryption algorithm. So this is what our two routers are going to need to agree to in order to set up this secure channel between these two pairs. So you might say, well, what are these 5 items? Because remember, OR1 and OR3 will need to abide by all of these. So the first one, a hashing algorithm. So what this basically is, we've got a choice of using either Message Digest 5 or Secure Hashing Algorithm 1. And what you can see here is what we've decided to go for is Secure Hashing Algorithm 1 and Secure Hashing Algorithm 1. So what we need to do is we need to agree on both sides which one to use. So in this case, you can see that we're going to be using the secure hashing algorithm. The next thing is our authentication method. So this is very, very important because again, this allows us to basically successfully authenticate with each pair on each side. And we can either do this using pre-shared keys, so essentially using a password, or using what's called this RSA, so using digital certificates. Or digital signatures, I should say. So again, what we're going to do is we're going to use a simple way. We're going to use pre-shared keys. And you can see the key that we're going to use here, guys, is VPN. So simply just a simple password, either side we're going to agree to. And this is really important that both sides agree to this password. If we don't have the same password, this essentially tunnel isn't going to come up and it's not going to work. Also, the next part of this, the G in our HAGL, this is basically used to do the key exchange. And what we have here is what's known as Diffie Hellman. And this is from two mathematicians. And what this essentially, what we can do here is we can set up a secure connection to establish shared secret keying material. So this is keys that can be used for symmetrical algorithms such as AES. So Diffie-Hellman exchange protocol itself is an asymmetric. It's a public key cryptography system, and it's very CPU intensive. But the whole idea of Diffie-Hellman is to basically use a public key cryptography method to basically establish a shared secret key. So if, for example, we have a man in the middle or two listening to the whole conversation between these two VPN peers, what will we do with Diffie-Hellman? Diffie-Hellman can be used to basically set up a shared secret key over this unsecure medium. So even though we're basically sending information between R1 and R3, R2 won't be able to understand or figure out this shared secret key that we'll establish using the Diffie-Hellman basically group. So that's very, very important. The next part, the lifetime, folks. So again, how long are we going to establish this IKE phase 1 tunnel for? And in this case, you can see we're establishing it for 86,400 seconds, which is essentially a day, 1 day. And then the last piece of this puzzle to set up this phase 1 tunnel is our encryption algorithm. So again, what will we use? Will we use DES, the digital encryption standard? Will we use triple DES, or will we use the advanced encryption standard? So in today's world, this AES is the most secure out of these three. So a lot of the time we'll choose AES, and this is the amount of bits that we'll use. Typically, the more bits in it, the longer, the better for the keys. Okay, so again, the more secure it is. So in this case, we're going to agree on both R1 and R3 will use the same AES encryption to establish our management peers between R1 and R3. So this will hopefully bring up our phase 1 tunnel because we have to agree to these. So again, just to summarize here, phase 1 tunnel is not used to encrypt or protect the end user's packets. It's only really used between R1 and R3 to establish a management kind of plane. What we'll see in the next video is we're going to see how we can set up basically the next stage, which is actually how we can encrypt the data over this tunnel. But before we do that, we actually have to go about doing, if you like, setting up this management tunnel. So let's do that now. And what I've got here is I've got the commands, and I'll share this up on our YouTube page. But essentially, here is how we go about setting up our phase 1 tunnel. And you can see what we have to do. The first thing we've got to do is we've got to set up a policy. And then in that policy, we set up the encryption we're going to use, the authentication, the Diffie-Hellman group, and essentially then what we do is we set up the other peer and basically the key that we're going to use. So what we're going to do now, guys, is we're going to actually type in this configuration. So let's bring up R1 and let's bring up our Word document so we have that side by side and you can see what I'm doing here. I'm going to go conft, and then what I'm going to do is I'm going to type in crypto, and you can see in this case ISAKMP and policy, and you can see in this case, guys, if we hit the question mark, what it's basically saying is what priority of protection suite you want to give it. In this case, I'm just going to select 10. And then what we're going to do is we're going to set out now our encryption that we're going to use. We decided in our plan we were going to use AES. So we can see encryption AES. And in our case, we want to set this to the number of bits. If I hit the question mark there, I can see that we didn't need to choose 128. Maybe if this was a production network, we might choose to basically use a higher encryption bit. We might decide to use the maximum, in this case 256. But for me, I'm going to use 128. And then what we're going to say is we're going to use for authentication, we're going to use a pre-shared key. Okay, so I'm going to configure a pre-shared key of VPN down the bottom in just a moment. And then what we're going to do is we're deciding to use the Diffie-Hellman group of 5. Now again, we're using 5 here because if I just hit the question mark, you can see that Packet Tracer only supports group 1, 2, and 5. But you can notice here in my exercise, it's saying that, the highest Diffie Hellman group supported is group 5. In a production network, you would configure at least Diffie Hellman group 14. And that could be even higher depending on what equipment you're using. But for us here, we're just going to use group 5 because that's all that our Packet Tracer supports. So once we've done that, again, what we'll see is, although that we had lots of different parameters up here, we can see that a number of defaults we were chosen. So we didn't even need to configure the lifetime, for example, because we're using the default, as can be seen here. Also, we didn't configure the hashing algorithm to be used, SHA-1 in this case, because again, that's automatically the default value. So that's absolutely fine. So what we're going to do now, folks, is we're just going to exit out of this. And then what we're going to say is, we're going to say crypto to finish this off, ISAKMP, and basically we're going to say key and our key that we're going to use. So in our case, we're just randomly, again, choosing VPN. We could choose any key name here. But what we need to do then is we need to say address, and we need to say the far VPN peer. So what we can say in this case is, we can see that our VPN peer is our R3 in this case, and the IP address of this is going to be 10.20.20.2. We need to get that correct. So now what we've done, just to summarize what we've done here, folks, we've established using our command line interface, we've now created our if you like, phase 1 tunnel. So this is going to bring up or start to set up our management, if you like, phase 1 tunnel. Now, obviously, nothing's going to happen here until we start bringing up our other peer, which is in our case is R3. But our next step is going to be, we're going to need to obviously set up the data plane or the data phase 2 tunnel. So at the moment, we've only done one part of this. And again, there's actually 2 tunnels involved. But what we'll do, folks, is now that we've done that, we've established phase 1, what we're going to do is we're going to stop and we're going to come back in our next video and we're going to actually do our phase 2 tunnel. So please join me back in a couple of minutes where we'll get started on phase 2. Thanks for viewing.